Hi there, Turgeon here, bringing you physics from afar. Temperature and heat. MCAS next gen computer based questions. What we're saying is that these are similar style to the types of questions you may see on the MCAS. You should also expect these on your upcoming test. I might literally take some off of here, so pay attention. As always, teachers making a video for you. Show that respect, unmute and listen, and you're respecting yourself because you're trying to gain that knowledge. Otherwise, what are you doing? You're taking the test and you feel like, I don't know what's going on. I need this explained to me. I need a person to explain this to me. Here's the person explaining this like a person. Number one, you read it carefully, you get all this table of values. It's very tempting because they say, oh yeah, just arrange these. So just, I don't know, WXY, YXW, I don't know. You don't go by feel though. In this type of situation, when they're giving you all this info, don't go by feel. This is begging for you to use the heat equation, Q equals MC delta T. We need the mass, we need specific heat, and let's remember, delta T is just one thing, so we need the change in the temperature. Now this is a little weird because they have the mass in grams. That's okay because they gave the specific heat with grams. Circle that, notice that. I'm going to be looking for you to circle that, and then I know you probably watched the video. And now I can put my numbers in, knowing that if you look down here, I know the change in temperature for all of them was 30 because they started at 50 and they ended at 20, and you subtract to get the change in the temperature. Look at the sample W, mass, M, mass, C, specific heat, triangle T, 30. That means multiply, so I get 135. That means multiply, I get 96. Different mass, different specific heat, same change in temperature, because it says they all went through the same changes. So now I can think which one had the least amount of heat released. This all happens to be heat released. These were all released because they went from 50 to 20. So if something goes down in temperature, that means heat was released. It lost heat. Okay, so that's the biggest number, so that's the most. That's the biggest number, so that's the most. You put either a W or an X or a Y. This was the calculation for W, this was the calculation for X, this is the calculation for Y. So that was the least amount of heat released, so the letter for that one goes there, and then you got something in the middle. Moving on. Okay, so it says, simple question, I guess, it says water changes 20 to 30. All right, that means more kinetic energy. Kinetic energy is not going to stay the same or decrease. Kinetic energy is going to increase. Can't decrease, can't stay the same. Look at number 3. A student has some water. They give the specific heat again in terms of grams, and they tell me the water in grams. Notice that correspondence, draw that line between the two. I don't need to do anything. The specific heat and the mass are both in grams, so they agree with each other. Also, I'm noticing from 20 to 80, that's a change in temperature of 60. Heat equation, mass, specific heat. They give it to me there. And the change in temperature. Okay, that ends up being 50,000 joules. It takes a lot of heat to change the temperature of water. All right, I'm going to explain this. You put this in your words. Listen closely. It says, what happens to the temperature of the water as it boils? The student is boiling. As it boils. As it boils. Not before, not after. Okay, well, let's go through this. This is solid ice. This is water. This is steam. There's these two in between. The ones I'm putting the dotted lines on are during the phase change, which is either melting or boiling. This one is boiling right here. This is boiling. So as it boils, the temperature is staying at 100 degrees Celsius, staying constant, 100 degrees Celsius. So I'm going to describe it. The temperature remains constant at 100 degrees Celsius. Why? During phase changes, the molecules do not gain kinetic energy anymore, they gain potential energy, like you saw in the last video. Part C, I'm going to be honest with you, it's kind of weird. I don't know what they're getting at here. It's a little bit weird. I think it's more about Part D. But if you look at the numbers, if you read them over and over, I had to read this 3 times, and all they're saying is, okay, so the water, same exact sample, same mass of water, and the same temperatures, 20 to 80, and it's water. So they say compare amount of the amount of thermal energy absorbed. Thermal energy absorbed is literally heat. That is heat. So the heat is the same. So I just compared them. It's the same as it was in Part A. Why? Because the same substance went through the same temperature change. The same mass of the substance, too. I think they're really just trying to set us up to answer Part D. Now, this time they say, okay, we're going to repeat this, but instead of the block being iron, it's going to be something else with a greater specific heat, maybe something like aluminum. And they're going to put this block in there. Okay, well, it's going to take more time. If you have more specific heat, greater specific heat, that means it requires more heat to change the temperature by the same amount. Therefore, it's going to take more time for it to absorb more heat. So the moral of the story for the MCAS is use the equation, know the difference between heat and temperature, understand phase changes and how, yeah, there's these sections where you have an increase in temperature, but a lot of times you just have constant temperature. Fix this diagram. If your diagram doesn't have these 0 and 100 lined up with those plateaus, then fix it. Don't just put them randomly. Those are not random. Those are supposed to line up with the horizontal parts. And the other moral of the story is molecules. Molecules respond to heat, sometimes by increasing the temperature, sometimes not. This has been Physics from Afar.